Okay, what we have here is we're going to go over these questions real quickly. Now, on this, what you have to do, remember, you have your mu and your standard deviation, okay? You need to make sure you draw your graph, fill it out every single time with the mu and standard deviation. Okay, let's go ahead and go through these answers. You want a percent that is less than 100. Well, what you do is that's your x value, so you find your z-score of negative 0.4. You then look at your orange sheet, which is your table A. You convert that to a p-value, and you have 0.3446. You can either say leave it at 0.3446, or you can say that 34.40% have an IQ less than 100. And since it's less than, we want to shade to the left. Okay? Now, on question number 2, we want to know that it's between. So between 90, which would be about right here, and 115, which is right here. We want the area in between. So what we're going to do is we're going to find the z-score of 90, which is negative 0.8. Then we're going to find the z-score of 115, which is 0.2. We're going to convert both of those to a p-value. This is 0.5793. This is 0.2119. In order to get the distance in the middle, what we want to do is we want to subtract the largest from the smallest. So we're going to subtract the largest from the smallest. And you get an area of 0.3674. Now, the next one, find the 80th percentile. Okay? It's given us our p-value. We got to figure out which p-value it is in between. It's actually closer to 0.7995. And if you look at 0.7995, that's a z-score of 0.84. I'm then going to use the formula for z-score. So 0.84. I don't know what score that is. That's what I'm looking for. Minus the average divided by standard deviation. Do a little mathematics. Add 110 to both sides, and you find that your score is going to be 131. So a score over here of 131, which would be about right here, notice I put it right here, is going to give you 80 percentile to the left. All right, next question. Question number 4. Find the IQ score which separates the lowest 25%. Remember, the lowest 25% is going to be to the left. So that's going to be this area right here. Okay? So over here, I took my 0.25. I found out what percentages it was between. It's actually closer to 0.2514. That equates to a z-score of negative 0.67. Same method as up here. Negative 0.67 is equals x minus 110 over 25. Multiply both sides by 25. Add the 110, and I get a score of 93.25. So a score of 93.25 is going to have 25% of the scores to the left. So that's 0.25. All right. Now, finally, in this next one, it's talking about the adult men in the Dinaric Alps. All right. Again, make sure you graph it. Get your mu and your standard deviation set before you do anything. All right. I want to find the 40th percentile. I'm not going to go through all of this. So the 40th percentile equates to a z-score of negative 0.25. Put it through the same mathematics as above. You get a score. You get a height of 72.25 inches. On number 6, this is what percentage have a height greater than 74 inches. So if you notice here, here's my 74 inches. I want the height that is greater. So remember, whatever you do, you're going to have to subtract it from 1. So I'm going to find a z-score of 74, or of a height of 74. My z-score happens to be 0.3 repeating. Now, since 0.3 repeating refers to the area to the left, you have to subtract from 1. So 1 minus 0.3 repeating gives me, if you look at the z-score of 0.3, that actually gives you 0.6293. All right, so if you do 0.6293, that's this area. Sorry, that's wrong. If you look up a z-score of 0.3 repeating, you're left with an area of 0.6293. You got to take that area and subtract it from 1 to get this area over here. And that's what I did here. 1 minus 0.6293 gives you 0.3707. That's the area to the right. Okay, on the back, question 7. What percentage of men have a height between 70 and 78? Again, you're going to find the highest, subtract the lowest. So I convert these to a z-score. Here are my z-scores right here of -1, and I have a z-score of 1.67. You can then convert those to a p-value, and then you subtract 0.9525 minus 1.1587, and you get an area of 0.7938, and you graph it accordingly. Question 8, here are the answers. I want the average height. What percent of the Denaric men are taller than the American man? So here's my American man. In Denaric, he would have a z-score of -1.33, which converts to a 0.0918 percentile. All right, so here's -1.33. Here's my area. I want those that are taller, so I'm going to subtract from 1. That means 90.82% of the Denaric men are taller than the average American man. What would be the minimum height to put the Denaric men in the top 10%? Well, I know that the p-value that I'm looking for is 0.10. I'm going to subtract that from 1 and get 0.9. So what that's going to give me on the graph, that's going to give me this area right here. Well, once I find this area here, I can subtract it from 1. So 0.90 is between 0.8997 and 0.9015. It's closer to 0.8997. That gives me a z-score of 1.28. I put it through the z-score formula. That gives me an x of 76.84. So when you come over here, if a person is taller than 76.84 inches, they are in the top 10%. Okay? Now, the last thing is about Asian elephant pregnancy. Again, fill out your graph. And here are the answers. I'm just going to show you the answers. The answer to number 9 is 659.995 days, which rounds up to about approximately 660 days. Number 11, you're looking in between, so you take the largest area minus the smallest area, and you get an area of 0.1894. Make sure you label it accordingly. Finally, number 12 and 13. Number 12, I want the shortest 20%. That means I'm looking for the area to the left. So 582 days is going to be about right here. So we want the area to the left. And then finally, I want the middle 50%. That means 25% is going to be to the left, 25% is going to be to the right. So I found a z-score of 0.25. I'm sorry, I found the area of 0.25. So that means that's a z-score of -0.67. If I have an area of 0.75, that's going to give me a z-score of +0.67. I then found my x's by plugging them into the formula. So this is a height of 588 or a pregnancy of 588.23 days. This is a pregnancy of 629.77 days. And therefore, when I subtract the two, or actually I don't have to subtract the two, I know that 50% are going to be between these 2 days. So if 5.88 is going to be somewhere around here, and 629 is going to be somewhere around here, and so that means 50% of the pregnancies are going to be between